Hello grade 12s and welcome to part 2 of 3 videos in which we will be naming organic compounds. Rule number 7 says that we should number the carbon atoms in the main chain so that the functional group is given the lowest number. Functional groups such as double bonds, triple bonds, hydroxyl groups, carbonyl groups or carboxyl groups are more important than substituents like alkyl groups and halogen atoms. So number 1, they must be given the lowest number, but also the main chain must always include the functional group. So in this case, in example number 4, we can see that the functional group is a double bond between two carbon atoms. This entire structure contains only carbon atoms and hydrogen atoms, and this is therefore an alkene, whose name is going to end with -ene. We need to now identify the longest continuous chain, and it must contain the functional group. We can see that this is the longest continuous chain. Now, on this long continuous chain, we can see that there is a branch over here, and there's also a branch over here. Both of these branches contain only one carbon atom, and they are therefore methyl branches. We start off by finding out how many carbon atoms there are in the longest chain. There are 6 carbon atoms, and therefore we will use the word hex to refer to the 6 carbon atoms. But we must show the position or give in the name the position of the functional group over here. The functional group must get the lowest number possible. So we're going to start numbering from the right-hand side. We have carbon 1, 2, 3, 4, 5, and 6. It is clear that the functional group falls on carbon number 2. Therefore, in the name we say hex 2-ene, where the 2 refers to where we can find the double bond. Now we need to name the methyl groups, or include the names of the methyl groups in the name, and we must also include the positions. The first methyl group falls on carbon number 4, and the second on carbon number 5. So we say 4, 5, because numbers are separated from numbers using commas, hyphen. Now, since there are 2 methyl groups, we're going to use the prefix di to refer to 2. So it will be dimethyl hex 2-ene. And this is the name of example number 4. We now move on to example number 5. The functional group in this compound is a triple bond between 2 carbon atoms. This is therefore an alkyne whose name will end with -ine. We now need to identify the longest continuous chain. But the longest continuous chain must include the functional group. In other words, it must include this triple bond. Therefore, this is the longest continuous chain. And we can see when we count that this longest continuous chain consists of 8 carbon atoms. So we're going to use the term oct to refer to 8. But we must tell the person reading where this triple bond is, where the functional group is. And as mentioned, the functional group must always obtain the lowest number possible. In this case, to give it the lowest number possible, we're going to number the carbon atoms from the left-hand side, and therefore this triple bond falls onto carbon number 3. So we call this oct 3-ine, where the 3 tells us where the functional group of the alkyne is. We're not done yet because there are also substituents. Specifically, we have alkyl groups or branches in this chain. The first is a methyl group because it contains 1 carbon. The second is an ethyl group because it contains 2 carbons. The methyl group falls onto carbon number 2, and the ethyl group falls onto carbon number 5. Now, you may be tempted to write down the position and name of the methyl group first because it falls onto carbon number 2. But we always name substituents in alphabetical order. So therefore, we're going to start off by naming ethyl before methyl because according to the alphabet, E comes before M. So over here we have 5-ethyl because E comes before M. 2-methyl, oct-3-ine. This is the name of example number 3. On to number 6. Here we again start off by identifying the functional group. The functional group is here on the first carbon. Even though it's on the right-hand side, it is the first carbon because it is where the functional group of this homologous series or this organic compound starts or is found. This specific compound is called a carboxylic acid because we can see a carboxyl group over here. The carboxyl group of carboxylic acids always fall onto carbon number 1. And therefore, we're going to number this compound or this molecule from the right-hand side. The name of carboxylic acids ends in anoic acid. Now we must identify the longest continuous chain that includes or has this functional group within it. And this over here is the longest continuous chain. When we count, we find that there are 7 of these carbon atoms in the longest continuous chain. And therefore, we're going to use the word hept to refer to these 7 carbon atoms. We don't indicate the position of the functional group because with the carboxylic acids, it will always fall on carbon number 1. So it is obvious where we're going to find the functional group. Now we see on this longest continuous chain, we also have substituents, such as a methyl group, which is a branch or alkyl group. And over here, we have what is called a halogen atom. A halogen atom, specifically, we have chlorine. When we name or number the carbon atoms in the chain, we find that the chlorine atom falls onto carbon number 2, while the methyl group falls onto carbon number 6. We always name substituents in alphabetical order, so that means we're going to start off with chloro because C comes before M. And so the name is going to be 2-chloro. We have 6-methyl heptanoic acid. Please always remember that your functional group is more important than the substituents. We can now move on to example number 7. In example number 7, we have the functional group falling onto the first carbon. And this compound or this molecule is therefore an aldehyde. The names of aldehydes end with a -nal. When we count the longest continuous chain, we find that it is over here. And the number of carbon atoms in the longest continuous chain is, in this case, 4 carbon atoms. So we're going to be using the word but to refer to those 4 carbon atoms. We don't indicate the position of the formal group. The formal group is the functional group of the aldehyde because it always falls onto carbon number 1. So its position is obvious, and that is why we just have butanol with no numbering in between. We have carbon 1, 2, 3, and 4, and we can clearly see that there are 2 bromine atoms on carbon number 3. Now, although both of these bromine atoms fall onto carbon number 3, we don't just write down 1, 3. We must indicate the position of both bromine atoms, so it will be 3, 3, indicating the position of both, di for 2 bromine atoms, and bromo for the bromine atoms. Therefore, this compound's name is 3,3-dibromobutanol. If you look at example 8, its functional group looks similar to that of example number 7. But the functional group is in between carbon atoms within the longest chain. So this is not an aldehyde, but instead it is a ketone. And the names of the ketones end in -one. The longest continuous chain must include the functional group of the ketone, and this is therefore the longest continuous chain. The number of carbon atoms in this longest continuous chain is 7, and we're therefore going to use the word hept. Heptanone. Okay, so over here we have heptanone, and we must indicate the position of the functional group. We have 1, 2, 3, 4, 5, 6, 7 carbons, and the functional group, this double bond O, falls onto carbon number 3. So we have heptan-3-one or hep-3-one, heptan-3-one. In the case of the ketones, you're going to find that we normally use this "an" sort of so that the word can flow better. So it's heptan-3-one. Now we see that there is a substituent or alkyl group over here. This branch contains 2 carbon atoms and therefore is an ethyl group. It falls onto carbon number 4, right? We've numbered the chain so that this gets the lowest number possible, and therefore the ethyl group falls onto carbon number 4. So this is called 4-ethyl heptan-3-one.